Well, welcome to the second half of Lesson 9.7, where we're looking at linearizing logarithm equations to be able to come up with a model. Now, in the previous video for this lesson, we looked at taking the logarithm of just a single variable. Well, in this lesson, we're going to be taking the logarithm of both variables. Now, how would you know to do this? Well, in the instructions, they'll tell you whether or not you want to take the logarithm of a single variable or the logarithm of both variables. Now, in the previous video, we also actually did the log of the common log of the variable, which can be kind of a pain because then when you type the log button in that one cell to come up with the equation, it always asks for the base. And so it's just one extra step to have to do. So in this video, we're going to be looking at how to take the natural log, actually, of both variables. Because remember, a logarithm of base e is what we're working with when we're using a natural log. So that's what we're going to do here. We're going to take the natural log of this information that's behind me. So I'll remove this wonderful video of myself so in that way you can see what those numbers are. So why don't you get out your calculators, because you're going to need those for this lesson again, or for the rest of this lesson. And you're going to put in this information into your calculator. So why don't I get myself out of the way here so you can do that. Okay, let me move this down so you can see all of this. So why don't you guys take a minute and just like before, why don't you go to your calculator. And you're going to want to go to a new spreadsheet. Now I already have one open like this. But you're going to want to go to, there we go. You're going to want to go to a new spreadsheet and you're going to call the first column D. Give yourself some space here, so leave this column open and then in column C, put the letter R and put in the information that is in this table. So why don't you guys take a minute and do that. So be plugging that information in. While you're doing that, let me just explain what this information is about. So what this is one way to compare the world record times between different events by measuring the mean time per 100 meters in each event. So for example, looking at this data here, this first number here, this 100 represents a 100-meter race. Well, the average, so for the world record holder, the average time there would be 9.69 per 100 meters. Where if you had a 1,000-meter race, someone's going to, in order to break that record or have that world record, they're going to have to pace themselves a little bit slower so they don't burn themselves out. And in that case, they're going to run each 100 meters in 13.2 seconds. Or if it's a 30,000-meter race, obviously they're going to want to pace themselves even slower yet. So for the world record, the average time here for each 100 meters is 17.8 seconds. So this is something that a racer could use, this data, to be able to figure out, well, if they want to break a record and they're running a 4,000-meter race, to figure out what pace they'd have to use, we would want to come up with a model to figure out what pace they'd have to use for every 100 meters in order to have a world record possibly. So again, so why don't you pause the video before you move on to the next step and copy down this information into your calculator. So pause the video and hit play when you're ready to move on to that next step. Okay, so you should have that information in your calculator now. And this time we're going to take the natural log of both variables. So we're not just going to take the logarithm or the natural log of one variable, we're going to do it to both. So in this column, I'm going to call this the natural log of D. Now again, I have this open on another screen here, so it's going to automatically fill this in. But you just do the natural log of D, and after you hit enter, nothing's going to happen. But what you want to do is you want to go into this cell, and just like before, if you have a diamond here, that means you have to put an equal sign to tell it you're going to use an equation. If it already has an equal sign here, well, then you don't need the equal sign. But we're going to do the natural log, so go over to the left and do Control e to the x. That's how we get this natural log, is doing Control e to the x. And we're going to tell it to take the natural log of the column A. If I did the natural log of variable D, it's going to ask me, well, do you want to use the numbers from this column, which we don't have anything there, or do you want to use it for the actual column A? So let's just do the natural log of A so we don't confuse our calculator. And then you should get these numbers in here now for column B. We're going to do the same thing over here, so arrow over and get to this column. And here we're going to take the natural log of this variable here, which is R. Again, when I hit enter, it's going to fill in this data because I already have it open. But in order for you guys to get this data, again, just like before, if you have a diamond here, you want to use the equal sign. If you don't have a diamond, you don't need the equal sign. If it just says equals there, remember you don't need the equal sign. So now we're going to do, again, going over to I'm going to hit Control E to the X to get the natural log. Now we're going to tell it to take the natural log of column C. And hit enter, and you should get these same numbers that I have on my screen now. So now going to a graphing screen, so not this graph, and that's second to the right here. We're going to go to just to the right of the spreadsheet where it says it looks like a histogram or a bar graph. We're going to organize this data. Remember, you could slide your cursor down, but I don't like doing it that way. Instead, just hit the tab button, and we're going to call this was the natural log of D, is what we did in this column, or for our X values. Hit the tab button again, and we're going to use for our Y-axis, we're going to use the natural log of R. And again, this data has a strong correlation here between the natural log of D and the natural log of R. So we're going to go to Menu, Analyze, Regression, and Show Linear. So we're going to round this to 0.1113 times X plus 1.76 as our answer. So our equation for right now would be this: y equals 0.1113 times x plus 1.76. But remember, x that we use in our graph there was not these numbers. It was the natural log of these numbers. So I'm going to replace x with the natural log of d. And remember, y wasn't just these numbers. Y was the natural log of those numbers. So our equation will be the natural log of r equals 0.1113 times the natural log of d plus 1.76. So that would be your equation. Now we want to come up with an exponential equation, is what this is asking us for. So what I'm going to do is I'm going to write this as natural log of r equals 0.1113 times the natural log of d. In order to get an exponential equation, I have to have all of these using the same logarithm. In other words, this 1.76, I have to figure out the natural log of what value would get me 1.76. So this is kind of tricky here, because basically what we have is we're trying to solve a logarithm equation to figure out what I take the natural log of to get 1.76. Well, remember when we're dealing with natural logs, my base is e. So I would write this as e to the 1.76 power. And if you do that on your calculator, you end up getting about 5.81. So here's what we're going to do. We're going to put 5.81 in there. So if I were to take the natural log of 5.81, I get 1.76. Now why is this necessary? Well, because we want to write this as a single logarithm. And that 0.1113 is an exponent, remember, for that d. So I'm on the track to write this as a single logarithm. So now I want to combine this as a single logarithm on the right side by multiplying these two values. So it's going to be d to 0.1113 times 5.81. And now our goal is to have an equation in exponential form. That means no logarithms are going to be part of our answer. So if I wanted to figure out what r is, I would just take, because I want both sides to be the same. So in order for me to figure out what r is, I would take d to the 0.1113 power, and multiply that answer times 5.81. And that answer would be this value for r. So in other words, you could just ignore the natural logs, and this would be your exponential equation. And we can use that now to answer a question. Because it says if a world record holder were to run a 15,000 meter race, we want to figure out what would be their mean time per 100 meters using that equation. So to do that, we're just going to replace 15,000 in for d. we would take 15,000.1113 times 5.81. And when you do that, you end up getting your answer of about 16.94 seconds. So on average, if a world record holder were to run a 15,000 meter race, that means that they would have to have about just under 17 seconds every 100 meters. Well, why don't we try one more? I want you guys to see if you can do this one on your own. So why don't you guys try this one? So why don't you plug this information into your calculator, and we can just call this A and this B to keep it simple. Or you can use D and R if you'd rather. Actually, that's what I think I'm going to use. I'm going to use D and R just like before. Now, you got to be careful, though. Actually, let's talk about that. Because if I were to go to a new screen, and if I were to type in D here and hit Enter, it's going to fill in what was already in a previous spreadsheet. And you don't want that, because if you just start deleting it, it actually still, even though you don't see it on your screen here, it still remembers it. So you don't want to do that. So instead, let's do this. Let's go to Home. Let's do New Document. It'll say, do you want to make any changes? Say no. And now if I go to a spreadsheet and I type in the letter D and hit Enter, nothing happens because it's cleared everything out. So why don't you guys go ahead and do a column for D and R here and put these 6 pieces of information into each column and then answer these questions on your own. So why don't you pause the video and hit play when you're ready to check to see if you have the correct answer. Okay, so you should have plugged that information into your calculator now. So we're going to take the natural log of both these variables. So again, just like we did before, I'm going to call this column ln of D. And in this spot, I'm going to have to put in the equal sign and tell my calculator to take the natural log of that column there. We're going to call that column A. Hit Enter and you should get those values. So go over here to column D. And again, this is going to be the natural log of these values that we have for R. So we're going to call this column ln of R. But in this gray box, that's where we actually figure out or tell it what to do. So again, Control E to the X power. And you want to do column C here and hit Enter. So you should get these values. So now we're going to go to our graphing calculator, or our graphing screen, and hit the tab button. We're going to put the natural log of D as our x-axis. Hit the tab again and do the natural log of R as your y-axis. And again, you can see this is a pretty close to being a linear relationship here, pretty strong relationship between these variables. So we're going to go to Menu, Analyze, Regression, Show Linear. So here would be our equation. Y equals we could round this to y equals 0.078 times x plus 3.6. So our equation again would be y equals 0.078 times x plus 3.6. But remember what this y represented. This y represented the natural log of these values for R. So I'm actually going to write this as the natural log of R equals 0.078. And x represented the natural log of that column. So it's going to be 0.078 times the natural log of D plus 3.6. So I want to rewrite this in exponential form, basically, is what this is asking me to do. So to do that, again, this 0.078 is an exponent for that value for D. So I'm going to say it's the natural log of R equals the natural log of D to the 0.078 plus, but I need to have a natural log of something here. So remember, this is where we got to figure out the natural log of what number would give us 3.6. Well, to figure that out, what we would do is we would say it's the natural log of x equals 3.6. Write that in exponential form, so that's e to the 3.6 power. Do that on your calculator, and you end up getting 36.598 as your answer. So now I can write this as a single logarithm. So it'll be d to the 0.078 times 36.598. So if I want an equation that's going to be solved just for r, my equation would be r equals d to the 0.078 times 36.598. That'd be my equation they're looking for. Then for part C, when it says if there were to be a women's world record in the 3,000 meter swim, estimate what the mean time would be from either equation. So we could use either equation here. Personally, I think it's easier to always use the exponential form. So we're going to put 3,000 in for your distance. So it'll be 3,000 to the 0.078 power times 36.598. If you type that in on your calculator, we get approximately 68.3 seconds. Is how much each 100 meters would have to be. So there you have it. That is how we work these problems out using your calculators. So good luck now as you work on your assignment.